So Bismillah Rahman Rahim. So let us start our module 3. So this module is about the modeling of the proposed 10-story building. We have three methods. I have discussed already the two methods in our previous module as well. That the method 1 is the the method 2 and 3 has been discussed. The method 2 was the using the quick draw templates of Etabs, and the third method was the using the grid lines in the Etabs. The first method is new, and we will be talking about this in detail. The direct import of the grid lines and the columns from the AutoCAD file, right? So before starting the method 1, so let us have a view on the architecture drawings that we will be following during the design of this 10-story building. The procedure will be the same. You must learn the design and the philosophies and the methods. So if you have the buildings like irregular building, or if you have any shape of the building, so you should be able to design that building. So this is actually a design course. So we are taking this case study building, but I have included some of the architectural features which we will normally deal with. So this is the plan of the basement. We can see this is the basement plan in which we have the ramp going up. There is a lift at this corner, and there is a this floor which is will be the raft is used as a parking. So we have another lift at the other corner, and we have stairs with it. And the total length of the building is 126 feet by 156 feet. Normally, as per the code, when the length of the building is greater than 150 feet or 140 feet, we have to provide an expansion joint. So there is no need of expansion in our building. So when you will be doing your real design projects. So when the building length is greater than 140 to 150 feet, then you have to provide the expansion joint. So we have the grids that is 14 feet, 12 feet, 15 feet, and then again 15, 12. On the other side, we have 19, 12, 20, 20, and at the end again we have the 12 and 19 feet, right? So this is the first plane. This is the basement plane. The next is the ground floor plane, in which we have the ramp. This is the projection of the ramp, and we have shops over this floor, and again there is a washrooms over here, and all the walls are resting on the beams except these areas. So remember that when the beams are resting on the walls are resting, these are the partition walls. When the partition walls are resting on the beams, then you have to insert or apply the wall loads directly on the beams. When the walls are not resting directly on the beams, for example, they are resting on the floors, for example, these washrooms, then you have to calculate the total weight of these walls, and then you have to apply the area load for the brick masonry partition walls or the slab. So that load will be transferred from the slab into the beams and from the beams into the columns. So this is the another floor. This is the ground floor. The next is the first floor, which is again are using for the shops as a commercial purpose. And the next floor is the from the second floor to top floor. It is very typical. It is used for the offices. So normally the architect will give you a simple dimension of the size of the column. Then you are the engineer, you have to decide the size of the column. But initially you have to check the size of the columns provided by the architects. So if they are working, that is fine, and if they are not working, then you have to increase the size of the column. So let us check the size of the column. In here they have provided the size of the column, 2 feet in this direction and 2 feet in the other direction, 24 plus 24 column. And this is the roof plane, in which we have the one mumti over here. There is over here water tank, and the another mumti in here. So there is a section A of the building, You can count the number of stories. These are the number of stories. You can see there is a parking, and then we have the passage, shops, and then we have the offices. You can check the uh, elevations or height of the stories from the section. Many things were clear from the section. So when you are doing your real design projects, you must ask the building section from the architects. So this is the basement level. This is the ground floor, first floor, second floor, third floor, fifth, sixth, seventh, and eighth, and then we have the roof. Right? All of the story have same elevations. Is height, it is 11 feet, so it may be vary from projects to projects. Then you have to provide those variable heights of the stories in your structural model. So the first method is to import directly the grid lines or the columns into the CAD file. For example, sometimes you will not have very regular structure like this. You will have columns irrespective of the grid lines, and it is impossible to draw the grid lines or the columns very properly, and the client will ask you to provide the structural drawings very soon, for example within 1 week or 10 days. So then you have to follow this method. Otherwise, the properly grid lines and the columns, they are very useful. You will see when you start your own designing. So the first step is to draw the grid lines in CAD file or columns at the desired location. Uh, it has already been drawn. The grid lines has been allocated. The uh, columns has been located on the desired locations by the architect. So if it is fine, then you have to go for the OK signal. And if it's not working, then you have to change the locations or the sizes of the columns. The next step is to give proper layer name to the grid or columns, and then you have to save it as DXF file and remove the remaining items. Right. So let us do this. We have to, because if the column plane is same for all of the building, for example in basement one to in ground floor and all of these, then you have to select only one plane, and then you have to do these changes. But if the plane is different, for example the column sizes are increasing, decreasing, or they for example they have included another column layout in here. For example, they have included in the ground this portion as well. They were, this portion was not included in the basement, but they have included in the ground floor, and some columns they have provided some columns in here. Then you have to import two planes of the columns or grid lines in your model. So let me delete all of these. First, let me save it. Save as, for example, grids. Let me delete all of these. You have to delete. Let me select similar. Delete these. Delete. Delete the dimensions. Select similar. Delete. And then you have to delete the H as well. You have to the only rectangular columns or the walls should be left to import is a DXF files. So this is actually a block. So you have to go to the block, delete this hedge. So it is now a simple rectangular. So let me select similar and enter X to remove the block from the columns. Now you can see it is a simple rectangular. How you can do with your own, you can draw a simple rectangular, example like this, and you have to import this simple rectangular without hedges or without blocks, so it will work. Otherwise it will not work. Right, so let me remove this as well. Now you can see this is not a block, this is a group. So we have to ungroup this. We have to remove this hedge. Now the Now this plane is ready. You can insert only, export only the grid lines, or you can also export only the columns. The benefit of using this method is when you have, for example, for example, you have a column like this. Let me draw a column like this. So using this method, the tab will automatically draw this column for you, and it will be available in your structure, right? So you can do it as with when you are doing the practice. And if you still have any question, you can ask. So now this thing is ready. Let us export this. You have to go to the file and then go to the save as. Click on the other formats. Click on the XF file. You can check other, but I have the AutoCAD 2013. Click on this, and for example, write it down the columns and save. Now you have to cross this open CAD file, otherwise this thing will not work. Let me cross this again. It will ask you to save it, so save it again. Again, select the columns, replace it. So now this thing has been saved. Now let us go to the E tab and click on the import. Let us open first the template, insert the data, for example 10 stories, and click on the blank. It will have the 10 stories, but we have to click on the blank. I don't want any grids. Click on OK. In the story data you will have 10 stories, but there is no grids, right? So now the next step is you have to go to the file, import, and click on the architecture plan, which is dxf/dwg file, and dxf file fits only where we have saved this only grids. Let me check that. Right. So let me undo this. Before importing the XF file, you have must have the same plane. For example, I have to select the story one. Then you have to select the story one when you are importing that file. Click on the file, import the XF architecture plane. So these were both are the same, that I have saved the column plane but only. Now here is the thing, then you have to select the same story in the plane which is open, right? So click on the story one and click OK. Now you can see that the plane has been imported, and you can check this is the column, right? Now the next step is to draw the column. You can draw it manually. For example, click on the quick draw columns and click on this. For example, this is the joint or the grid point. You can draw the columns like this, but this is very laborious job. I want to draw it very quickly, so there is another method. You have to go to the model explorer, click on the display, model windows, click on the view plane, architecture layer, and there is a layer name is column, and you right click on this and click add column objects. So it will draw the column objects for those rectangular objects named as columns. Now if I go to 3D, you can see these are has been added. For example, let me undo this again, and let me select all the stories and click again on the right click on the column, add column objects, and you will see that the columns will be generated in all the 10 stories. So this is the how you can draw it very quickly. The next is, for example, these walls, the shear walls, you can draw it. For example, these are in the walls. Right click on this, add wall objects. Now you can see these walls has been drawn. If I go to the 3D view, these has been added in your model. The next step is to draw the beams. You can also use these, for example, if you have defined the beams, you can right click, for example, it was this, you can add the beam objects, but it is very lengthy process because you have to draw each and every beam connected to the center of the columns, and it will take a lot of time. So it's better to draw the beams in their Etab, not in the CAD file. The how you can add the grid lines. For example, if I go to the options, click on the architecture plane options and deselect all, and you can see there is no grid lines created by the Etabs itself. Those grid lines were they imported from the CAD. I want to draw my own grid lines. So you have to again go to the option, click on the architecture plane option, select all, and again this grid line has been named as G, which is grid. Click on this, right click, add grid. So now the grid line has been drawn. How you can verify this? You can go to the option, turn off these architecture planes. Now you can see those grid lines that were defined in the CAD file has been drawn on the in the ETAB. So what are the benefits of the grid lines? That you can quickly draw your beams and you quickly draw your slab. For example, I want to draw very quick beams, so I have to select the quick draw beams and drag a window, and it will draw all the beams within one click. And similarly for the slab, you can draw quick floor slabs, and just in one window click you can draw your beams and slab. If I go to 3D, you can see that the beams and the slab has been drawn very quickly, right? So these are some benefits of the grid lines, and you must have the grid lines. But if you cannot draw the grid lines or the structure is very irregular, so then you have to go and draw the beam manually. For example, let me undo this, and if you do not have any grids, let me undo this again, and you have to go to the draw beam columns, and you have to draw this manually by clicking on the joint to joint. For example, this joint, it's taking time because we have selected all story command. Let's click one, so now it will be faster. So you have to draw the beams just like this manually. Similarly, you have to draw the slabs manually, just like this. Or, for example, like this. So these are the different methods uh, which can be very useful in the modeling of your structure. The next one is the wall stake, which we have discussed earlier. So we will be modeling it very properly. Let's go to the method 2. So this was the whole story which I have explained it, that the after saving the DXF file and removing all the items, import this DXF file in the same story in which they currently open, which I have explained that if your plane is open in story 1, then you have to select story 1. And if you've opened plane view of ground floor, then you have to select the ground floor due to the importation of the DXF file. Now save the file and start the modeling of the ETAB using these architecture drawings. The next method is to using quick draw templates of the Etabs, and this was the information I have given you in the previous lecture, that you have to insert the data in the different tabs. For example, the number of stories, height, number of grids. Then you have to select the slab system, beam slab system, flat slab system. Define section properties for the columns, enter load data, edit grid spacing. Click OK, propose building model will appear, save the file and start working on the model if there is any changes. Let us go to the E tab. So now this was the template we were using yesterday. This is the 10, this is 11, and how many grid lines we are having in the X in the Y direction. This is the design data, picture drawings. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 grid lines in the X direction. In the Y direction, we have also 10 grid lines. So we have to insert 10 and 10 in here and leave this as, for example, 20, and click on the custom grid spacing, edit grid data, and click on the spacing. So what the ETAB is doing is it will start from the ABC. This is the ABC. This is ABC, and this is 1, 1, 2, 3. It's starting from the base, from the bottom to the top, and uh, uh, from the right to from the left to right side. So from left to right side, we have the spacing in the X direction. We have the spacing of 14 feet, 12 feet, 15 feet, 15, 12, 15, 15, 12, and then 14 again. So we will start with from the 14 in the X. We have 14, and then 12, 2 times 15, 12, and then 2 times 15, 12, 14. 2 times 15, 12, 14. Now the X has been done. Now let us go to the Y. You have to start it from the base to the top. It is 19, 12, and then we have 1, 2, 3, 4, 5. 5 times 20. 19, 12, and this is 1, 2, 3, 4, 5 times 20, and after that we have 12 and 19. 12 and 19. Click on OK. And the next step is to go to the two-way slab. This is template, and click uncheck this ribs. It is two-way slab, and this is the column beams X in Y direction. This is the slab. If you want to define these properties in here, you can go to the this tab and you can define in here, but we will be defining it in our next lectures, so we do not need this. So if you want to add the loads, you can add loads, but at this time we do not need any loads. We have to click on the fix rigid, click OK, and then we have to click OK. Now the structure has been modeled. as per the architecture drawings. Now you can add your shear walls, your openings for the stairs, and your ramp. Let us select all these stories. Select all. Click edit shell, divide shell with the intersection of the all of these. Click OK. So it will divide the shells into smaller shells. For example, we select this. So if you want to delete a few shells, they are disturbing the path of the ramp or the stairs, you can delete that very easily. Right, so let us save this in the models 10 stories. So this was the one method. The next method, if you want to add the load data, which I have explained earlier, the next is the grid lines in the Etabs, that you can insert the data for the buildings, like different tabs, number of stories, grid lines, which is similar thing, but you have to only click on the grids. How we do that? Let me add a new template, and if you insert, for example, this is the 10, 11, 11, and again this is 20, 20, and this is the custom only grids. You can change this in here as well. If you do want to change it, you can change it in the inside of your model. Right click on the add modify grids, click on the show modify grid system, and click on the spacing. Now you can change the spacing of your desired. For example, this is the 20 20 20, right? And then you have to click OK. For example, this is the desired uh, grids for your building, and then you have to draw the columns, beams, and the slabs for your desired building, right? So let us move to the actual modeling for building, which we have the example 10 story. So let us draw all of these retaining walls and left walls. So this was the whole story about the method 3. The next is the stairs and the partition walls. Modeling of the stairs take a lot of time and have no significant effect on contribution the overall performance and the stiffness of the building. Sometimes stairs do not have any beam column support as it is built over 4.5-inch walls. So therefore, designers do not model stairs. Although if someone wants to model it, he or she can, right? The partition walls, the unconfined brick masonry or the concrete masonry wall cannot be designed in E-tabs, as the frames are designed with the elastic analysis and bricks will go under the inelastic range during the design earthquake, which I've explained earlier in the question or session, in the previous sessions. So it can be modeled in ETAB using the strut following the FEMA 356 procedure, but it is very lengthy process and normally adopted during the structural health assessment of the existing buildings. Therefore, loads of these partition walls are to be taken in the design process. So this is our story 10. Let us go to the story 1. Let me open the architecture. So this is the actually a plane, basement plane. The slab of the basement will be the ground floor. So we will be checking this whether there is an opening or not. So there will be opening for the ramp in the 1, 2, 3 grids. So you have to delete these two. Example 1, 2, 3. These slabs will not be. Let me delete this grid line as well. Let me go to the there will be no beams as well. So this thing will be open, and there is lift walls which size is 10 cross 10 feet, and there is also lift of 10 cross 10 feet, and there is an opening for the stairs. Let us draw the lift it first, then we will go towards the stairs. So there is stairs in the first grid, for example in here the 9 and 10. So we have to delete these. The beam cannot be passing through the stairs, so this beam should also be deleted. We will draw this later on. And there is a column missing, that there should be a column in here, but it is disturbing the stairs, so that why it was removed. So the purpose of putting this column in the stairs, that you have an idea that sometimes the architect will place columns in irrespective or irregular places, then you have to change the location of the column. For example, you can move it at the end, but because the span is not that much large, for example 17 feet, so there is no need of the column in between these grids. So that's why we have removed these columns, this column and this column and this column. Let us select all stories, so it will be deleted from the all stories, like that. So let us draw the lift wall. Let us go to the wall stake, click on the single lift. The clear length of the lift is 10 feet in the x and the y direction, and the wall thickness is initially we will take as a 12 inches because it is 10 story, and we will talk about the thicknesses of the wall, that what should be the thickness of the wall as per the code. And the opening is normally 4 feet, uh, and we have to verify this whether it is 4 feet or 10 feet. It is 5 feet, so then we have to insert the value of 5. Click OK. Now you can see this is the lift wall, but the direction of the lift wall is not the same as in the architecture drawing, so you have to change the its orientation, for example 90 degree, and we have to click on this point, click OK. So now this lift wall has been modeled. Now you can insert this in the other portion as well, and we have to insert the example 180. It is not 180, minus 180. Click on this point, click OK. Now delete these areas disturbing the lift wall, and the column of this grid is located near the lift wall, so we have to move that because it's disturbing the stairs, and there is no column in this point, so we have to remove this column as well, and you have to replicate, move this, select this column, having the alt story command, go to the edit, replicate, select 2 points, delete the original, pick 2 points, this point and this joint, click on apply. Now it will be shifted from this point to the other point. Now draw the remaining area. This beam cannot pass through the stairs as well, so you have to delete this beam, this grid as well, because this will be the portion of the stairs. Now you have to draw the remaining portion for the slab. Click on this point, click on the edge, this point, And similarly for the other stairs as well, this much. This is 10 feet. So let us draw a dummy beam, which is none, and give offset of 120 inches, which is 10 feet. So it will be from here into here. So now this is the boundary for the stairs. Let us delete this and let us draw the slab. This thing. Now draw the remaining beams, or you can edit this beam by selecting this beam. Example, click on this reshape object, just like this. So this is the modeling for the lift walls. Let us draw the retaining wall, which is all around the building, right? And the thickness is given by the architect is 1 feet. We will talk about the minimum thicknesses for the walls. Let us click on this draw walls, or you can draw the quick draw walls because we have grid lines. 8 pair spandrels auto ID, make it yes. You can select the property for the wall because we haven't defined any property. So let us select the wall 1 and let us drag the window for this point, and from this point to this point. So sorry, this is the all story command is selected, so you have to turn it off into the one story. This is one story, one story. Now draw the remaining portion manually, or you can edit this by for example, let me move the beams. We have to draw this separately. Let's go to 3D. Now you can see the model is ready. Now one thing is left is the Orhora tank, and the how many times left in the 15 minutes. The ramp is from this grid. We have to left this one grid, and this is actually a slab because the car will come here and then it will go down, and it is from the first into 1 2 3 4 5 in 5 grids. Let's go to the view, set building view limits. We have to see only story 1 at the upper, and the bottom is base. Click on OK. Let us remove the grid lines, set grid lines to disappear. So this is the point. Click on the draw slab and select, for example, a property of slab 1. So there will be a beam and slab, you have to insert that as well. And the grids is 1, 2, 3, 4, 5. 5 grids. This is, click on this point. This is one grid, 1, 2, 3, 4, 5. So in here, this point, this point, this, and go to the plane, story 1. Show the grids. Click on the quick draw area, quick draw beam. So the car will come here and it will go down, but the two grids should also be not included in this, because there will be clear no clear height for the uh, car. So we have to remove this shop as well. So we have to remove this, delete this. So this is the ramp. Now draw, this beam will support the starting point of the ramp. Now the next point is to draw the ramp beam. Click on this point. For example, this is the beam, complete beam. The starting point into the this point, and again this point to the this point. Now you have to divide the columns that are intersecting these beams. Go to edit frames, divide frame at the intersection, these beams. Now you can see the column has been divided at the intersection part of the ramp beam, right? So now the model is ready. Only one thing is left, is the MOMT and the overhead water tank. Let us add a new story, quick story. Give it as a, for example, 6 or 8 feet. This is our, and let's see as moment. Let's go to the plane, select this and this. Actually, this you have to make the frame, and the or water tank will be in the first, second, third, fourth. In the fourth and the third, first, second, third, fourth, and the third. So these two is the water tank. Select this and go to the replicate and replicate it into the story 11. This is the Momti and the water tank. We delete this. Let us see this have it is. Draw the slab for the Momti. Now it will cover the left wall as well. Draw the walls for the water tank. We will assign the different properties to these structure elements in the next session. Now you can see the model is completed and it is ready. Let us go to the view, show the rendered view. You can check it out. This is the Momti. This is 1 momti second, and this is the overhead tank. This is the ramp, opening of the ramp, and this is the beam of the ramp. Right. So let me save this so we can do the changes or assign the structure uh, thicknesses or members to these elements. So this is the whole story of the module 3. So if you have any questions, you can ask. Let me finish this